measures or is not behind any firewall, this scan is best for targets like that. So we got the most information using -A. But besides this -A, let us also check a few more useful options that Nmap gives us. And to do that, we're going to run the Nmap manual. So type man and then Nmap, and it will open up the manual once again. We already know how we can go through it with upper and lower arrow. And we're going to just go really quick through it and see whether there are any useful options that we haven't covered, but that you might want to use. So if I go down here, this -SN option is really useful option. And it is not really useful for discovering vulnerabilities or open ports. Matter of fact, this option right here performs the same thing that our NetDiscover tool did. Remember, we use NetDiscover to locate all of the hosts that are up and running on our network, and -SN pretty much does the same thing. As we can see right here, this option tells Nmap not to do a port scan, so you will not find out any open ports with this scan. The only useful thing we get from this is which hosts are up and running. So let's test it out real quick. And this is a scan that you would use probably on multiple machines to discover which ones are up and which ones aren't, but you can also use it on one machine if you'd like. For this scan, I will use my home network, so -SN and then 192.168.1.1-255. If I press enter, this should pretty much in just a few seconds, and here it is, it will give us which hosts are currently up. We get their IP addresses, so 192.168.1.10, this is my laptop. We get the Metasploitable, we get Windows 10 probably, and we get my router. So instead of NetDiscover, you can use this to figure out which hosts are up. But for me personally, I like NetDiscover output a little bit better than this one. This right here looks a little bit messy. Okay, so the second thing that I want to show you is -P option. And this is an actual option that you will use a lot. So for this, we're going to scan our Metasploitable, so change the IP address to the Metasploitable IP address. And what -P option is simply you can specify what range of port you want to scan with Nmap. So remember, when we perform any other scan, it scans top 1000 ports. But what if we, for example, only wanted to scan one port? For example, let's say we wanted to scan port 80 on the Metasploitable. Can we do that? Well, if you specify -P and then 80, and then the IP address, here it will tell us port 80 open and service that it is running. So we can scan only one port if we want. This option is useful if you're only attacking one port and you don't want to bother really and let Nmap scan 1000 port when you only want to enumerate one single port. You can also do it on multiple ports, for example port 80, port 22, port 100, and let's see what the output is. And here we can see port 80 and port 22 are open, while the port 100 is closed. We separate different ports with comma, and instead of separating them with comma, if you want to scan a range of ports, you can also do this. You can do port 1 to port 100. And here are the results. Not shown, 94 closed ports, and we got 6 ports that are open in first 100 ports. And remember when I told you that there are over 65,000 ports? Well, this is the option that we can use in order to scan all 65,000. If I type the same command, just I scan from 1 to 65,535 and press enter, this scan will take longer than any previous scan that we did, since it is scanning 65,000 ports. Here we can see the output, it finished in 7.74 seconds, and here are all the open ports that it managed to discover. Here are some of the ports that we never really discovered with previous scans that we did in last few videos. So this is really useful. If we used regular scans and we only scanned first 1000 ports, we would never really know that these ports are also open. Now, on the contrary, instead of scanning 1000 ports or 65,000 ports, we can use a cool option, which is -F, and it is capital F. And what this option does is, instead of scanning 1000 ports, it scans first 100 ports. So in case you want to perform a quicker scan, and you also want to scan top 100 used ports, you would use the -F option. If I press enter, you can see it finished in less than 1 second, and it scanned top 100 ports. Now this doesn't mean that it scanned port from 1 to 100, this simply means it scanned first 100 ports that are usually most used. So we got 21, 22, 25, 53, and a bunch of others as well. But whenever you really want to find out everything you can about the target, this scan will be more useful. The one where we scan 65,000 ports, since you can see there are a lot more ports that are open than with this scan. Okay, cool. Let me show you one more option before we proceed to the next video. And that option is how to output an Nmap scan. So there are a few ways that we can do that. If I run Nmap and then we use the synscan, which we covered, and let's say we scan the Metasploitable, there are two ways that we can do this. If we want the output to be inside of a file, we can use two arrows to the right and then output of scan.txt. Let me see, you requested the scan type which requires root privileges, so let us run it with root. And press enter, type in password, and you will see we get no output to our terminal. That is because all of the output is stored in this file. If we use the cat command to output the results, here is our scan that is being stored inside of this file. So this is useful once you want to, for example, add this to your report, so you just save it in a file and then later on copy and paste this on a report. Another way that you can do this, in case you want the results to be saved both in a file and also outputted in your terminal, we can use the -on option. So -on, I'm not sure if it is with capital N or lowercase n. We're going to check that out with the help menu. So let's go to the output settings, and it is -on option. And we can see right here -on option is output scan in normal. So we can simply just save this in a normal file. If you want some other file type, you can use OX for the XML. And we got some other options here as well that you might find interesting. For now on, we're just going to check out this one. So if I go down here and type nmap -on and then -ss, of course we need to run this with sudo. And we specify 192.168.1.5. Output file begins with, we need to specify the name of the file that we want to save it, so let's just call it output. And here it is, we get the output to our terminal, but if I also type ls and cat the output file, we also get the results saved inside of this file. Okay, great. These are just some of the basic options that I wanted to mention, since you might find them useful. And by now, as I already told you, you can consider yourself an intermediate Nmap scanner. Now to take this to the advanced level, we're going to check out in the next few videos how we can bypass firewall, IDS and IPS using Nmap scans. In this small section, we're going to cover how we can use Nmap in our advantage to be able to bypass some of the security measures that the target might have, such as firewalls and IDS. These options that we will use in Nmap can be considered advanced, so don't worry if you don't fully understand everything that we talked about in next few videos. Just make sure that in case there is something that you didn't understand, rewatch a video a few times and you will get it. But wait, Alexa, I don't even know what firewall or IDS is. So what are they? Well, firewall is a network security system that monitors network traffic, and it is based on the security rules that are predetermined. There are two types of firewalls: network firewalls and host-based firewalls. Network firewalls filter traffic between two or more networks, while host-based firewalls only filter traffic that is going in or out from that specific machine. And what IDS is intrusion detection system. It is usually a software application that monitors the network for any malicious activity. For example, some of the Nmap scans that we did in the previous section can get caught by intrusion detection system. So in this section, we will check out a few options that could help us bypass that. All in all, firewall and IDS helps us secure our network or machine. In the previous section, where we covered Nmap basics, we used our Kali Linux machine and we scanned our metasploitable target. We scanned different ports, and with the scans that we did, we managed to figure out what ports are open and what ports are closed. But some of our targets might host services on ports hiding behind the firewall. And once we scan them, it will tell us those ports are filtered, which we know that it means Nmap can't figure out whether that port is open or closed. What this means is that we're sending packets to that target, but their firewall keeps dropping those packets. And in this section, we're going to see what Nmap options can help us in bypassing this. Let's get straight into it. Let us talk about different options we can use in our scans to bypass firewall. Firewall is something unpredictable. You don't really know its rules in order to know exactly what type of scan you need to perform in order to bypass it. Some of the firewalls could use MAC address filtering in order to allow certain devices to connect to a specific port, or in order to block a certain devices. Some firewalls could block different types of packets. Some firewalls could block only some ports and not all of them, and we can't really know what the exact rule is. What I'm going to do is I will give you a few different options as to what you can try in order to bypass firewall. First of all, how can we know if some of the ports on target machine are behind a firewall? We already mentioned this in the previous video. Nmap will tell us that those ports are filtered. By now, we should already know what filtered port is. But let us define it once again. Filtered port is when Nmap can't figure out whether a certain port is open or closed, and that is due to it dropping packets, possibly because that port is behind a firewall. Therefore, we don't get any responses back from that port, and Nmap flags it as filtered. Let me show you this on a Windows machine. Right here, I have Windows 7 virtual machine. And this virtual machine, if I go to the control panel, and then system and security, and Windows firewall, this machine has firewall turned on. If I try to scan it using SynScan, which we covered in the previous section, so let's do it right here. Remember, it requires sudo privileges, so sudo nmap-ss, and then the IP address. I will use the IP address of my Windows 7 virtual machine. And if I press here enter, type in the password, in just a few seconds the scan will finish. And we're going to compare this result when the firewall is turned on with the result once we turn off the firewall. So let's wait for this to end. And here it is. It doesn't have any port open. Matter of fact, it will tell me all 1000 scanned ports on this PC are filtered. Now, this doesn't mean that all could be closed or all could be opened. This just means that they are behind the firewall, and any packets we send get dropped by that firewall. So our target could have a few ports open and other closed, but we don't really know that. Let me show you the response of the same scan once we have that target turn off their firewall. So let's go to Windows machine, and I will click on this turn Windows firewall on or off. And in both of these settings, I will select turn off Windows firewall. Click on OK. And now, once the firewall is turned off, let us perform the same scan that we did right here. So we'll just use upper arrow, run the same command, and here it is. We can see that some ports are indeed open. This firewall right here doesn't have any special rules since it is made to block all traffics, so techniques that I'm about to show you in these few videos will not work on regular machines that just turn on their firewall and that don't accept any type of connection. However, once firewall rules are applied, and they usually are applied in some servers or machines that need remote access or that need to communicate with other machines, then we can test these options and see whether those rules have any vulnerability that we can bypass. I will turn the firewall back on, right here. I will close this, and let's start with our first option. We're going to use an option -f. So if I clear the screen and type the command sudo nmap -f and then the IP address, this -f option causes the requested scan to use tiny fragmented IP packets. Now you might be wondering, why would we do that? Well, the idea behind this is to split TCP header over several packets to make it harder for packet filters or intrusion detection systems to detect what you're doing. If we specify the option once just by adding one -f, the nmap will split the packets into 8 bytes or less. So if your packet had a 24 bytes TCP header, this would be split into 3 different packets of 8 bytes. Now, you can also specify the option twice with -f and then once again -f, and this will split the packets into 16 bytes per fragment. But be careful once running this option on an actual target, as some programs have trouble handling these tiny packets. If you want to increase fragment size even more, you can use the option --mtu, and after it the fragment size. Just remember that offset you specify must be a multiple of 8. This fragmentation won't always work. If I run this scan, this option will not work most of the time actually. It only works if a network that you're scanning can afford the hit that this will cause. Therefore, they just leave it disabled. Some networks also can't enable this because fragments may take different routes into their networks. Nonetheless, it is good to mention this option, as it might come in handy one day. Another option we can use, which is more focused on hiding your IP address than bypassing security, and that option is creating decoys using -d. So if I specify dash and then capital D, creating this decoy scan makes it appear to the target as it has been scanned not only by you, but also by the decoys that you specify. So their intrusion detection system might report multiple IP addresses that scan them, including yours. But they will not be able to determine which one is real. So you successfully hid your IP address from them. There are 2 ways that we can do this. And just to show you how this works, what I'm going to do is I will open a software called Wireshark on my Windows 10 machine. And with this software, we will be able to see which IP addresses are communicating with my Windows 10 machine. Now, you don't need to have Wireshark for now, just pay attention to the scans that we perform and results that we get in Wireshark. Right here, I will select Ethernet, since that is what I'm currently using, and we should already see some packets coming in. But these packets right here have nothing to do with our scan. So if I go back to my Kali Linux, and I run the command sudo nmap -d, and to specify how many random IP addresses we want to use to scan the target, we can specify -d and then rnd, 2 dots, and then the number of IP addresses we want to use. So in this case, I will use 5 random IP addresses. If I press enter right here and go to my Wireshark, it doesn't seem to be flooding anything. Are we successfully scanning? Oh, that's right, we are scanning Windows 7 machine, my bad, so we need to be scanning our Windows 10 machine, so let me check the IP address of my Windows 10. ipconfig 192.168.1.7, and right here I will just change from 16 to 17. And let's go back to Wireshark once again. It doesn't seem to show for some reason. Let us try adding this command, and we will use the synscan to perform this. Press enter. And the reason this might not work is because sometimes Wireshark will have a problem capturing the packets that we send from a virtual machine. And that is mostly because we're scanning our host machine from the virtual machine. So what I'm going to do is I'm going to go to my laptop and run the same command. Give me just a second, and I'm running the same command that we ran right here. I just ran it, and if I go back here Here we can see now the output. We can see that our Windows 10 machine is getting flooded with random IP addresses. If I stop it, I can see different IP addresses right here. So we got 193.245.213.77. We also got the other IP addresses, but I will also see my laptop's IP address, and it kind of sticks out. Since this R&D option that we used creates random IP addresses, all of those random IP addresses will be truly random, while the only IP address that will stick out will be this 192.168.1.10, and that is a local IP. So this will most likely not work. They will recognize it as the true IP. So how can we change this and make it seem like the scan is coming from 5 local IP addresses that belong to my home network? Instead of running the command like this, what we can do is we can run the command like this, so sudo nmap and then -d, and after -d we specify 5 different IP addresses including ours. So we'll specify 192.168.1.2. Let's also use 192.168.1.5 for example. Let's use 192.168.1.6. Let's use 192.168.1.15. And let's at the end use my IP address. And to specify the Kali Linux IP address, we can simply type me. What this command will do is it will use these random IP addresses to scan the target, including our true IP address. So all we need to specify is the IP address of my Windows 10 machine. And if I run this, go back to Wireshark. Yeah, of course, once again, I must run this from the actual laptop in order for this to work. So what I'm going to do is I'm going to run the same command in just a second. And I'm running it right now. If I go to my Wireshark, here we can see now it is getting flooded with local IP addresses. We can see 192.168.1.2, .1.5, .1.15, and .1.10. And they will never really realize that this one is the correct IP address, since they are getting flooded with a lot of them. And you can change this number, you can use more IP addresses if you want, or less. But the point of this is that in case you're scanning a target that is inside the same network as you, use local IP addresses. And in case you're scanning the target that is outside your network, you can use this option right here, which will generate random IP addresses. And the security will have a hard time figuring out which one is the correct one. Cool, right? Now, don't worry, since this didn't work on my Windows 10 machine. The only reason it didn't work is because my Kali Linux machine uses the same network interface as my Windows 10 host machine. If you were to scan any other target except your host machine, this would work in every case. So for now, we looked at these two options, and in the next video, I will just quickly mention a few more options used to evade security, and then we will proceed to vulnerability analysis, which is the last step before we start gaining access to our target. We mentioned fragmented packets and creating decoys in the previous video. Right now, we're going to mention a few more options, and even though they are not that important, it is good to know they exist, so let's go through them real fast. I will not be running these options, but you can test them out if you want. I will just mention them so you know what else you can use. The first thing we got is option -s. And you run it like this, sudo nmap -s, and this option is used to spoof your IP address. It will make your target think that someone else is scanning them. The problem with this is that you will not get results of scan back, since they will be sent to the IP address that you're trying to impersonate. So for example, you can be trying to impersonate 8.8.8.8, and your target will be scanned with this IP address, or at least it will seem that the scan is coming from this IP address. For this option to work, you must also specify -pn, and the reason why you must specify -pn is, first of all, -pn is used to assume that all hosts are online, so it doesn't perform the ping scan to discover whether a host is up and running. Without the -pn, this option would not work, and the reason is because your target will be scanned with this IP address. And we will not be able to get the packets back and see whether the target is on or off. That's why we will just assume that the target is online, so we can scan them with a different IP address. Otherwise, we would never get the result whether they are online. And sometimes with these two options, you must also run -e. E is used to specify a network interface. So you would simply just type ifconfig, check out what network interface you're using, and you would specify it right here. In my case, that would be ETH0. Another cool option besides this that Nmap has is you can specify the source port with -g option. This can sometimes help bypass a firewall. For example, a network administrator may set up a firewall and set a rule where only traffic from a certain port is allowed. And with that, he's probably thinking that attackers won't be able to figure out from which port exactly. And if you perform a scan and send packets from the port that's allowed in the firewall rule, you successfully bypassed firewall. So you would specify it with -g and then random port number. And one last thing that we will mention that could help you in bypassing firewall is changing different scan types. We already covered some scan types, and any of them could be useful to you sometimes. For example, in case you perform a SYN scan on a target machine, and in case the SYN scan is blocked by the target's firewall, which would mean that they drop all SYN requests that try to initiate TCP connection, we could try to perform a FIN scan, and FIN scan is labeled like this, -sf. Now, you're probably confused because there are a lot of scans that we can do. And in case you don't have any networking background, you're probably wondering what FIN scan even means. Well, FIN scan is just sending a FIN packet without any other flags. And these SYN flags and FIN flags can be confusing sometimes, but with practice you will catch everything up. Just one advice I have is that every time you don't fully understand something, just Google it. That is how I learned as well. And all of these options that we covered can be combined with something called timing template. And to show you what timing template really is, I opened up my Nmap manual right here, and I scrolled to this option right here, which says -t, timing template. And if you also open up Nmap manual, this will be all the way down. So there are about 1 or 2 minutes of scrolling until you reach this option. Here in the Nmap manual, we can see the -t comes with 6 different options or 6 different modes. And what's interesting for us regarding security evasion are the first 2 modes, which are 0 and 1, also called paranoid and sneaky. These 2 are used for IDS evasion, as it says right here. Now, the problem with T0 and T1, or the first 2 options, is since they are trying to avoid IDS alerts, they will take a lot longer to finish. So once you're scanning more machines or more networks, this might not be the most reasonable approach to take, since this scan will take a lot of time with specifying -T0 or -T1. And all of this, including the options that we covered in the last video, will help you in security evasion and spoofing. What I would advise you to do is also read about other options as well that we didn't cover, just to see what else can you do. In the next video, big things are happening. We're going to create our first tool used for penetration testing. Let's do it. Welcome back. We're about to start our first coding project. Are you ready to create your own first tool for hacking? We're going to create our tool using Python 3. And since Python is out of scope for this course, I won't be explaining Python basics. However, I will give my best to explain what we are exactly doing inside of our code for anyone that hasn't programmed before. Now, I know what you're thinking, programming is not needed for hacking. That is true. However, learning programming will help you understand how different tools work in greater details, and it will also allow you to create and weaponize your own tools that you can use. My advice for anyone that is learning ethical hacking and penetration testing is to, at some point of your journey, learn a programming language. since if you're only using tools that other people create, you're limited to their tools. Now, these programming projects you can watch as we go through the course, or you can skip it until you finish entire course and then get back to them. It is completely up to you. Nonetheless, let's get straight into creating our first tool. Here we are in our Cal Linux. So how are we going to approach this? Well, for some of you that already have programming experience and already know Python, feel free to code this program wherever you want. You can code it on your host machine, you can code it in your Cal Linux machine, whatever you feel the best. You can also use any editor you want. But for you that haven't programmed before and have no idea what I'm talking about, what we're going to do is we're going to open our terminal. And inside of our desktop directory, we're going to create a directory called tools. Now you will notice we got it right here on the screen. And if I change the directory to that directory, right here we will create our program. And we're going to put our code inside of a Nano editor. Now we are already familiar as to how we can use Nano. So to open a file, we want to type Nano and then the file name. In our case, we are creating a Python program, so it needs to have extension.py. And since we just finished our scanning section, we will be creating a port scanner. It will not be an advanced port scanner like Nmap, but we're going to see how we can create a simple one just so you better understand how scanning of ports work. So let's type nano and then portscanner.py, and this will automatically open up our file. Here we're going to type in our code. The reason why we are not using anything else to type in our code is because Nano Editor is really simple and easy to use. First thing that we're going to do is we're going to import the libraries that we're going to need for this project. The first library is called socket library, and we import them like this. This import command just loads this library. And we need this library to be able to communicate with other machines using TCP and UDP protocols. And another library that we're going to use is called termcolor library. And we're only going to need this library in order to print some statements in different colors. So nothing else besides that. Let us create the base of our program. So the first thing we need to do, whenever we are creating some type of a connection over TCP or UDP, we need to initiate a socket object. And socket objects are also called socket descriptors, and they are used for internet communication. To initiate a socket object in Python, we can call that object sock, for example, and to initiate it we type equals and then socket.socket. So what we're basically doing right here is we're calling this library and calling the socket function from that library. This will initiate the socket object for us and it will be stored right here. And all we're left to do, since Python is an easy programming language, is we need to connect to our target and our port. And for that we're going to use our socket object and the connect function onto our socket object. This connect function requires two different parameters that we specify between two open and two closed brackets. And those parameters are IP address and also port. But these are something that we have not defined yet. Our program does not know what an IP address is or what the port is. So what I'm going to do is I will create a function right here, and to initiate the function I just type def and then the function name. This function name will be called scanPort, and it will take two parameters which will be these two parameters. So let's copy them and let's paste them right here. These are going to be the two parameters that our function will take. And these two lines of code will belong to our function. In order to make them belong, you just tab once both of these lines and they will belong to this scanPort function. Now that we try to connect, there is logically one thing that we need to do. This connect function will either succeed, so we will manage to connect to a port, or it will not succeed. We won't be able to connect to that port. So these are two different options. Once we manage to connect, that means that the port is open, and if we don't manage to connect, that means that the port is closed. And what we're going to do to figure out whether a certain port is closed or opened, we're going to use try and except statement. And to specify try and except statement, we can do something like this. In the first line of our function, we type try, and then we tab these two lines to belong to the try statement. And down here, we also add except. Make sure to add two dots at the end. And what this simply means is that inside of our function, it will try to initiate the socket object, and then it will try to connect onto a certain port, on a certain IP address that we will specify later. If it manages to do that, then we can print something like print port opened. We can specify something like this. If it doesn't manage to connect, then it will proceed to this except statement, and then we can print port closed. Alright? So simple as that. Now there are a few things that are wrong with this function. First of all, we're just printing port opened. So once we try to connect to a port, we will not know which port is open, which port is closed, since we didn't specify a number. To specify exactly which port is open, what I'm going to do is type port opened, and then plus, and then I can specify string of port. And remember, port is our parameter for our function. And what this string function does is it converts the port, which is an integer number most likely, to be a string. So it can print it out using this print statement. What I'm going to do also is add space right here so we print this more nicely. And right here I will add the plus sign, which means that we successfully discovered an open port. And down here, we're going to do the same thing. So we're going to print minus sign, which means port is closed. And then we're going to add plus the string of port. Another thing we will do in case we find out an open port is we can close the socket object. Since we successfully completed an action, we found an open port, we can close the socket object. Okay, so this is our base function. For now on, we're going to leave it like this. But there are a few more things that we need to specify. First of all, we want to prompt to the user of this program what IP address or what target they want to scan. So outside of this function, we can create a variable called target or targets, whatever you like. And that variable will be equal to input. And this input function allows the user of the program, once they run the program, to input any string that they want. And here we will specify to them that we need a target. So enter target to scan. Once they enter a target, we can also ask them for port to scan. Now trust me, I know what you're thinking right here. This is too simple. We're only scanning one port on a target. So we don't really want to do that. We want to specify right here ports. So this will be enter how many ports you want to scan. So they can scan 100 ports or 1000 ports or all 65,000 ports if they like. But how are we going to change that inside of our code? Well, we're not going to touch this at all. What we're going to do is we'll create another function called scan. But this just starts the same. This one doesn't have the port inside of the name. And this scan function will take two arguments as well. And those arguments are going to be the targets and the ports. And all we are going to do right here is we're going to iterate. So for port in range from 1 to ports, for each and every port, we're going to call scan port function. And this scan port function, remember, takes two arguments. And those two arguments are going to be targets and port. And let me explain this a little bit better. What these two lines do is this will iterate from 1 to any number that they specified right here inside of this line. And then it will call for each and every number the scan port function. So it will start from 1 and then it will scan port number 1 using this function. then it will increase port to be 2, and then it will call scan port function once again, once the port is equal to 2, and it will do that until it reaches the port's number that the user of the program specified right here. But what if our user wants to specify multiple targets? What then? They, for example, don't want to scan only one target, they want to scan 2 targets. That's why what we're going to do is we're going to change this scan function, and this scan function will take target as an input, and it will scan the port on target. But notice this target is something that we don't really have. If we call right here scan target and then ports, we have targets, but we do not have target. And we're going to change this targets variable to be enter targets to scan. And inside of the brackets, we will explain to them, split them by comma. So they can specify, for example, 2 targets. They can specify them like this. They want to scan 192.168.1.1, comma, 192.168.1.5. For example, if they specify it like this, then we have a problem. We will call the scan function on one target, but we need to split this input so it scans this IP address, and then after it, it scans this IP address. Let's see how we can do that. For now, down here, what we're going to do is we're going to check if there is comma inside of our targets variable. If, and to specify that, we open single quote, type comma, and close single quote. If comma is in targets, this means that they specified multiple targets. So what we're going to do is we're going to go down a little bit and then print, and then open double quotes. We can specify this star sign just so it looks a little bit better. Scanning multiple targets. And let's close the double quotes. And then right here what we can do is instead of calling the scan function outside of the if statement, we're going to call it inside of the if statement. And what we're going to do is we're going to use a for loop inside of this if statement. So for IP address, and we're going to call it IPADDR, in targets dot split, and this split function simply splits the input that the user specified by any sign that we specify in between these single quotes. Now, since the users of this program will specify targets with comma, we also want to split the input with comma. That way, we're going to get with 2 IP addresses that don't have this comma in between them. And for each IP address in this targets variable, we're going to scan IP address, and let us strip it out of any empty spaces. And we do that by typing strip, open the brackets, single quote, space, single quote. And the second parameter we will leave to be ports. In any other case, in case they specified only one target, we're going to use else statement, and in that case we are simply just going to scan targets and then ports. So we're just pasting the entire input of this variable inside of the scan function, and that is because they only inputted one IP address, because there is no comma inside of this variable. So let's go through this real fast, just to figure out everything a little bit better. Let's go from the beginning of the program, which is down here. So we ask the user for the targets. They can specify either one target to scan or multiple targets to scan, separated by comma. Then they specify the ports that they want to scan, and by specifying ports I mean the amount of ports that they want to scan. So if they type 500 right here, our program will scan first 500 ports. Once we take these 2 variables and we take the input from the user, we check whether comma is inside of this targets variable. If it is, that means multiple targets have been specified. Then we go for each IP address inside of this targets variable, and we check out those IP addresses by splitting the input with comma. Then we will scan each and every IP address with the specified amount of ports. In case they only specified one IP address, then we scan that one IP address with the specified amount of ports. Once we go to the scan function, this will go for port in range 1 to the amount of ports specified, and it will perform the scan port function for each and every port. If we manage to connect, we will print port is opened. If we don't manage to connect, we will print port is closed. Let's see whether this works. If I Ctrl O, then enter, and Ctrl X to exit. To run this program, I can use Python 3 and then portscanner.py. It asks us enter targets to scan, split them by comma, and what I'm going to do, I'm going to scan my router. What you can do, you can open and start your Metasploitable, and I'm going to start it right now as well, just so we can test later the multiple target scan. And I'm going to type the IP address of my router, which is this one. Press enter, enter how many ports you want to scan. Let's say I want to scan first 100 ports. And we get our first error. Now, don't worry, errors occur a lot in programming. Let's see what the error says. String object cannot be interpreted as integer, and it is inside of this line. Let's check it out. Let's go back to our program using nano, so nano portscanner.py, and let's see where the error is. It seems to be right here. So we are pasting this ports option as an integer, but we are taking an input as a string. So what we can do is we can wrap this ports input inside of the integer function, which will convert this number into an integer. Let's try and see whether this fixed the problem. If I type it once again, 192.168.1.1, and then ports 100. Wow, this finished really fast. And we can see it scanned 100 ports. It managed to find these two that are open, and this one as well. Let me just find it. And this one as well. Now, I know what you're thinking. This is a terrible output. We can barely see which ones are open and which ones are closed. So what we can do to fix this, we can go back to our program, and in the except part where we print that the port is closed, we are not going to print anything. We're just going to pass. This pass simply means do nothing and continue with the execution of the program. Why we do this? Well, we don't really care which ports are closed. We only want to print the ports that are open. So let's see whether this fixed our program. If I type Python 3 port scanner and I run the same IP address, which is my router, first 100 ports, there it is. We get a whole lot better output. We only get ports that are open. Let's test this program on two different targets. So I started my Metasploitable, and what I'm going to do is log in, check the IP address of my Metasploitable, which is 192.168.1.5, and if I run the program once again and type 192.168.1.1, which is my router, and then comma 192.168.1.5, press enter, enter amount of ports, let's say we want to scan 100 ports, and this will work, but it gives us the wrong output. We don't know which ports belong to which target. So let's go back to our program and see how we can fix this. To fix this, we're going to add a print statement inside of our scan function. Right at the beginning, we're going to print. First, we're going to start with a new line character, and the new line character is \n. Close the single quote, plus, and let's open single quote once again, enter space, and then type starting scan for, another space, and then single quote, plus the string of the target. And remember, target is our argument to our function, and this target is an actual IP address that we split right here. Here we paste this IP address inside of the scan function, and this ipaddr.strip is the same thing as this target right here. So if I print it like this and close two brackets because we have one bracket opened right here, let's test it out once again. Ctrl O to save, Ctrl X to exit, and let me run the program once again. First 100 ports. This is a lot better. we get which ports are open for my router, and we also get which ports are open for my Metasploitable. Now, with this, our program is basically finished. What you can do to make this better is you can change the output a little bit. So right here where you print scanning multiple targets, we can use the term color library that we imported, and from that term color library we can take the colored function. And this function just changes the color of our print statement into any color that we want. So what we need to do is inside of the print statement type term color.colored, open bracket, type the statement that you want to print, close one bracket, type comma, and then open single quote, and let's say we want to print this in green. And then I need to close two more brackets, one for the colored function and one for the print function. Let's see whether this will work. Ctrl O to save once again, and Ctrl X to exit. Python 3, portscanner.py. Unmatched bracket. So let's check it out. Yeah, we do got one bracket more. Let us go back and remove it. So we got print bracket closed right here, and we got the colored bracket closed right here. So yeah, this one right here is 1 too extra. Let's delete it. Save it once again. Run the program. Type any two targets that you want to scan. In my case, I am using router and Metasploitable. And I want to scan, let's say this time I want to scan first 200 ports. Now, it doesn't seem to print it in green for some reason. Let's see what the problem is. If I go all the way down to our print statement, right here it seems that our colored function only took this as an argument. And we want it to take this as well. So what we need to do, we first of all need to delete this. What we need to do is open another bracket right here and close another bracket right here. Now this does seem confusing with all of these brackets being open and closed, but what we just did is we extracted this statement to be one function. So inside of the colored, we open one bracket for the function itself. Then we paste two arguments and we split these arguments like this. And first argument is this print statement, while the second argument is the color that we want to print it in. Hopefully right now this will work. And if I go and run the program once again and scan first 200 ports, now it seems to work. It says scanning multiple targets and it is printed in green. As we can see for our Metasploitable, we also found two more additional ports because we increased the number to 200. Cool. Now you got your first tool ready to use in your penetration tests. Now, even though this is a simple port scanner, you can do many things to make it a little bit better. If you are an experienced programmer, what you can do, you can try to receive a banner from these open ports. So you can try to send packets and receive packets and store the response inside a variable and then print it out to see what banner does an open port have. And banner is just something that an open port might send as an information as to which software it is running on that open port. And from that banner, we can also extract the version of that software. But we're not going to be doing that right now because that would be a little bit too advanced for us. Right now we're happy with this program. In the next few videos, we're going to be covering vulnerability analysis. See you there. Welcome to the vulnerability analysis section. So we covered scanning and we managed to discover a bunch of information about our target. And right now we're going to use that information to discover whether a target has some vulnerabilities. We're going to cover 3 different tools in this section. And the first one is going to be an already familiar tool, which is called Nmap. We're going to tackle a subject on Nmap scripting. By now, we learned that Nmap is used for scanning targets. But Nmap can also perform vulnerability analysis, and in some cases it can even perform exploitation with the help of different scripts. As this is advanced use of Nmap, we should first explain what are these Nmap scripts. Well, Nmap scripts are commonly used in scanning to detect different service vulnerabilities. It can also be used for brute forcing attacks. It can be used to detect a malware on target machine. It is also used to collect even more information about databases and other network services. So we can consider this lecture to be half scanning and half vulnerability analysis. The goal of this lecture, however, will not be the vulnerability analysis, but to show you how we can run these scripts. And before we even run them, we need to know what are our available options. So, where are those scripts? How do we run them? How do we know which scripts even exist? Inside of the Kali Linux, we can find all the scripts that Nmap has inside of this directory. So, open up your terminal and navigate to user share /nmap and then /scripts. If I type ls right here, we can see there are a lot of them. Let us test some of them out and see whether they give us any information about our target. Now, running scripts comes with two different options. We can either specify one script to use in a scan, or we can specify a group of scripts that we will use inside of a scan. And to fully understand all the possible things that we can do with scripts using Nmap, you should take a look at this page right here. This is the official Nmap page from the nmap.org link, and in the /book/nseusage.html, it will give us a good explanation about script groups and the usage of Nmap. If I scroll all the way down, here is the usage and examples. We get different script categories, which are script groups. We can see right here that the currently defined categories are auth, broadcast, brute, default, discovery, and many more right here. And down here we can read about each and every one of them to see what each script group does. So for example, right here, the brute script group, it says these scripts are used to brute force attacks to guess authentication credentials of a remote server. Nmap contains scripts for brute forcing dozens of protocols, including HTTP brute, Oracle brute, SNMP brute, and so on and so on. Let us test some of them out. Let us start with this auth script group first. We can read these scripts deal with authentication credentials or bypassing them on the target system. Examples include X11 access, FTP anonymous, and Oracle enum users. Now, these right here that you read are single script names, and these single scripts belong to this larger script group. Right here it also says scripts which use brute force attacks to determine credentials are placed in the brute category instead. So right here, there are no scripts that are used for brute forcing. And what brute forcing simply means is running a bunch of usernames and passwords onto the target system to discover which one is the correct username and which one is the correct password. But more about brute forcing later on. For now, let us go and test some of these scripts. To run a scan with the script group, we can use nmap --script, and after it, we specify the script group. So in my case, I will use auth, and I will scan my metasploitable machine with the synscan. Remember, synscan requires sudo privileges, so let's add sudo and type in our password. As soon as it finishes, we're going to see whether this auth script group discovered any useful information for us regarding vulnerabilities. Okay, so it has finished. Let us see whether our script managed to detect anything unusual. So we get the standard output of all the open ports, and we also get some other information for some of the ports. For example, right here we get FTP anon, and this FTP anon is just a single script name from the Nmap. It tells us that anonymous FTP login is allowed. What does this mean? Well, this is something that we will cover later. For now on, just keep in mind that anonymous login is allowed for the port 21. Under the SSH port, we get which authentication methods are supported, right here. Down here we get information for the SQL port. It tells us that root account has empty password. This can also be very useful for us. And right here we can see Tomcat, Tomcat. What does this mean? Well, this looks like a default Tomcat credentials. And if I go down here, it tells us post-scan script results. It says that this is a valid credential for Tomcat. It is for the service running on this port. Let us check this out. This might be the first vulnerability that we find. To check whether this is correct, we can go and open up Firefox. And we're going to make a connection to our Metasploitable on this port right here. So just find out the IP address of your Metasploitable. And if you scanned it right now, you already know it. So for me, it is 192.168.1.6. And to make a connection to a port, I will type 2 dots and then the port number. In my case, what seems to be a vulnerability is found on this port. So let's copy the port and I will paste it right here. Oops. It seems that it only pasted the port.